everyone, and this is Chloe from CHLOEMEJUSTME. And what some of you may or may not know is that I'm actually home educated, and I learn in a completely different way to most people. And Mel Science helps me do just that through hands-on experiments, which makes me feel like a real scientist. Mel Science consists of a starter kit and a subscription box, which is sent monthly, with 4 to 6 experiments. See that little icon right there? I want to click it. It has my last Mel Science review video. Please check it out first. Over here, I have 2 subscription boxes. One, which is electricity versus metals, and 2, colourful chemistry. I'm really excited for this one. Because apparently, you can use different compounds and liquids to make colourful water. Trust me, it's a lot cooler than it sounds. I really am excited for this one, but I'm going to save the best for last. So, electricity versus metals it is. It said, before you start, secure your smartphone or tablet on the stand provided. Next thing on the list, launch Mel Chemistry app. I got the phone on the stand. I got the stand from the starter kit. So, I've selected Zinc versus Electricity. I'm going to click on it. And as you can see, there's a video, and I'm going to watch it to know what to do.
Welcome to the wonderful world of chemistry. Today, with the help of the Metals vs. Electricity set by Mel Chemistry, we will make an image on a copper disc with the help of zinc and electricity.
Over here we have steel versus electricity card and a zinc versus electricity card. We're going to be doing the zinc because it's shorter and easier to show you guys. I will need an abrasive sponge and a copper disc. I will also need zinc sulfate and zinc wire and some crocodile clips and a battery pack. Oh, and I need a cup and a plastic tray. Right here, I have a copper disc, and over here I have an abrasive sponge, and I'm going to rub the abrasive sponge on the copper. Let's see. I'm rubbing it because I need to remove any problematic materials on the copper. So I've got to draw any pattern I like on both sides of the copper now. I'm going to see if I can replicate a penny. There we go. That should be good. Now let's flip it over. I'm just going to draw a little pattern on this. Yay! Here it is. Now I need to prepare the solution. Yeah, I need to use zinc salt, which is this one here, and which is the second metal used in the process. So I'm going to pour one whole bottle in there. I know it looks small, but trust me. And then I do water. I need to pour water. Pour precisely. There we go. Now I need to connect the positively charged electrode to the zinc wire. Where's the zinc wire? It's in there. Yeah. And now I need to connect this one. And now I need to connect this to the battery pack with the batteries in. To the red. And now I need to get the black and connect it to the coin. here and connect this one to the black wire. I need to put the red one in there and the copper one in there, and that should work. I need to wait a minute. Oh, actually, all of it really working. You can see it just rubbing off and making the cream go grey. As you can see, there's a reaction happening. I was not expecting it to be that quick. Look at it! There's tiny little bubbles coming off. Oh, look at the teeny little bubbles. And I think I need to flip it over now. There we go. What's happened over there? It's not completely black. It's now black. It's now black. It's now black. What do? It's black. Now I've got to place it in there. And I need to rub it thoroughly. Rub it until it clears the crayon off. And hopefully we should get a really cool coin thing. Okay, that worked. That definitely worked. You ready? Ba ba da ba da ba da da. Da da da. Look at that. I like the pattern on the back. That looks really cool. Ah, I got a little coin with a pattern on it. Look at it shining in its light and all its glory. That's really cool. But you can repeat the experiment. Mind blown. So it's basically created a zinc layer copper coin. But if you want to find out more, you can quite easily go to the website in the link in the description. Go check it out. It's awesome. I told you I'd save the best for last, and I did. We will be doing this. And I'm going to show you some magic. Magic liquid, that is. So this is a colourful chemistry box. I'm going to be doing the magic liquid experiment. There's 3 experiments in here. There's magic liquid, the one I'll be doing. There's colour changing milk, and acidic patterns. I don't need these 2 because I'm going to be doing the magic liquid today. And in the magic liquid, I just need lots of cups. First, we need to prepare the pH indicator vinyl blue solution by putting one. You have a big spoon right here, or a tiny big spoon. We're going to fill it to the rim with this. And we need to pop it in here. Now I need to use the water and pop it in here very carefully to there. Oh, I need more water. There we go. Perfect. I'm just going to place that on the side, and now I'm going to put a few drops of sodium hydrogen sulfate in this cup, a few drops of citric acid in these 2 cups, a few drops of sodium carbonate in these 2 cups, and a few drops of sodium hydrogen carbonate in that cup. Now we're going to add the universal indicator. It's turned orange. See what this one turns into. And that one's green. That one's red. Very reddy orange that one is. Yellow. Blue. Don't change colours. I feel like a scientist now, trying to kind of get my flash and be like, ah. And on the card here it says, pH indicators are substances which, when added to solution, change colour corresponding to the solution's pH value. One can determine a solution's pH according to the indicator colour. Here are the various possible colours of the pH indicator, thermal blue. This is pH 1, this is pH 2, pH 9, pH 10. The yellow can be on either side. It can either be pH 3 or pH 8. And over here it says water solution pH. There are not only molecules of water H2O in aqueous solutions, and also other particles, molecules and ions. pH is an important solution characteristic which is determined by concentrations of hydrogen H+ and hydroxide OH ions. If a solution has an excess of hydrogen ions OH, its pH will be higher than 7. It is said that such solutions are basic or alkaline, which is really cool. That's kind of the basic idea. This was my favourite experiment, especially because I really love pH scales. And plus, isn't it strange that I'm age 10 and my favourite colour is blue, and this is pH 10, and it is blue. That's really cool. I hope you enjoyed my Mel Science experiment review. If you'd like to see more like this, click here. If you'd like to subscribe, click here. Please like and comment in the description below. And don't forget, I put every single thing you need to know about Mel Science in the description, so go check it out.